This is not the end of our notes, but we're going to be dealing with closure here. This is for our functional dependencies and normalization for relational databases. More videos about the information that we've previously covered can be found in the playlist linked below the like button in the description. But now we are going to be skipping through these and going over closure. This is for functional dependency closure and attribute dependency closure. So if we have like F plus, this is going to be our functional dependency closure. So we have F plus closure for F. The set of all dependencies that include F, as well as all dependencies that can be inferred from F, is called the closure of F. So we have the set of dependencies including F that's going to be inside of here. It's going to be this first circle. And then we have the dependencies that can be inferred from F. We've done a little bit of inferring earlier. And this is included on the outside. This is the closure for our F. So we have our inside, the dependencies, and then the inferred from dependencies on the outside. Now it's similar for attributes. For attribute dependency closure, we have this X plus. It's of our X under F, the set of attributes that are functionally determined by X based on F. X plus can be calculated by repeatedly applying IR1, IR2, IR3, and these are just previous attributes using the FDs in our F, and FDs are functional dependencies. We've gone over those as well. So now we are going to look at a large example on the algorithm to calculate our X plus. So we're going to determine our X plus, the closure of X under F. So to do this, we have some instructions here. Basically, we have our code, and we have X plus, which is the closure, and we're setting our closure equal to X. And then we're going to repeat. We have our old X plus, so our old closure, and if it's equal to our new closure, and then we're going to set it equal to our new closure. We want to repeat this. Now we have for each functional dependency, so we're going to check each one. We're going to have our Y go to the Z in F, and then we're going to have a do. So this is do. We're going to do this. Do if our Y is a subset equal to X plus, and if this is true, if Y is a subset of X plus, then X plus, which is our closure, is going to be equal to our closure with a union of our Z. And this is going to run until we have our old X plus equal to our just X plus, the old closure equal to the new closure. Now, that is a little bit hard to think about, so we're going to do an example for this. So this is an example on how to calculate our X plus. So let's just say we have F is equal to, and then we have our social security number and our e-name. We're also given our P number, so like a project number, and with this we have a project name and a project location. Then we have our SSN, social security number, and our P number, and this goes to hours. Well, let's check the very first thing. Our FD1 is social security number going to e-name, our P number is going to the P name location, we have this as our F2, and then we have our FD3 down here. So let's look at our first loop, loop 1 right here. We know that this is it has a for loop right here, so we're going to want to loop. On the first loop, remember, we have our X plus equal to our X right here. So the first time we do this, we are going to start this out by setting our social security number plus equal to our social security number. This is our start. And then for the next one, we are going to have, we're checking the FD1. We're checking the very first one. We have our social security number, and we're setting it to the union, the subset of social security number. Is this a subset? Well, we can see for FD1, our social security number is right here. This is going to be true. That's how we would look at it. We are going to look at this part right here. And then after we do that, we are going to set our X plus, which is the social security number, plus. We're going to set it to our social security number union with the other part on the right, which is our e-name. And so this is going to give us the SSN is equal to our e-name. Now we want to check the other ones as well, because we're doing a loop for this. So we checked the first one. Now we need to check the P number. Well, for this one, P number is not equal to our new X plus, which is our social security number e-name. So that's out. And the same thing with our FD3. It's out. Just because of this P number. We can see that it's not going to equal to each other. So that is it for our loop 1. This is now what our X plus is equal to. So now we have to do our loop 2. Well, the first thing that we're going to want to do is we're going to want to set this because we're repeating right here. We're repeating until. So on our repeat, we're setting our old X plus equal to the new one right here so that we can write in it. So we have SSN and then our e-name. And then we're going to check our FD1. So is this right here a subset of our x plus? Well, yes, because our SS1, our SSN, is inside of our x plus. So now we're just going to union it. So we have our SSN, and then we have our SSN, comma, this should be an E name because we've just checked if it's a subset. So SSN E name union with our E name. Well, this is just going to give us an E name. That's because we're unioning it with our old x plus. So unioning it together, this is what our new x is going to be equal to. Pretty similar to the previous one. Now we're going to check our FD2 and our FD3. These don't work. Now we are at our until. So this bottom part. And we were at the until last time, but the old x plus was not equal to the x plus when we did our first loop. Now it is though, because we can see our x plus is equal to our SSN and our E name, and our old x is equal to our SSN and then our E name. Since they're equal to, we're going to finish. And since we finish, we're going to set our SSN plus equal to our SSN E name. That's going to be our result. We have this information down here, but we're not going to touch on that, as we're skipping over that. So that's going to be it for our closure. We've done closure, and next we're going to look at equivalence of sets of FDs, functional dependencies, and then we're going to go over minimal sets, but those can be found in the playlist link below the like button.